Thanks a lot for this invitation. I'm really honored to be here today and join you in this WASP for All conference. I'm Barbara Plank. I'm associate professor at ITU Copenhagen, and I'm working as a researcher in natural language processing. Computer scientist by training and moving into this field quite some time back in my master's studies. And I'm currently leading a small research group here at ITU in NLP. And what I'm showing you today is essentially a bit of an overview of what's called multitask learning and applications to NLP. I'm very happy that we heard already a bit about language processing. And let me see if I can remove this. I will just leave it. I'm very happy that we heard already a little bit of language processing and the need of NLP in other areas earlier in Amy's talk, but also in the talk on what H&M is doing. So I'm really sitting into that field and perhaps give you a little bit of another talk than what we have seen so far. And I'm happy to answer your questions at the end. So if you look at what the field is really doing is we want to understand and produce human language, and so to process this with computer and AI methodology. And our field has really made really huge processes in recent years, but there is a lot to be done still in this area. And what we actually mostly still rely on is supervised learning. So it's about learning from input to outputs. And these input-output functions are typically XR texts in my area, but can also be linked to visual. And you want to learn distributions of labels like sentiment, or like machine translation, or some more structured predictions problems where you're interested in finding relations between entities and so on. But what all of these tasks, or what's typically done, is that you're learning a model for each of the tasks that you are facing, and you are relying a lot on human annotated examples, which can also be noisy, but we really require this labeling to learn currently. That's what's driving the field at the moment, at least, and that's very time intensive, expensive. So the question is, how can we do better than moving from one task to the next and leveraging synergies between information and tasks in order to improve our models? And in fact, typically we relied a lot on single task learning, and the question is, can we do better than that? And this is what my talk today will focus on. And in particular, I will gonna go into multitask learning, and my goal is to give you an overview of an MTL in the field, a little bit of a historical talk, and then in the end also touch up on some recent work we have been doing and give you a bit more details, zoom in a bit more in that. But what is multitask learning? The key idea is essentially, instead of learning two tasks separately from scratch, is you want to learn a model in parallel, or you want to share knowledge between models or tasks in order to improve the modeling. And this can be done by many different ways, but the simplest approach is to essentially share the model structure, and then in the end have typically a main task you're interested in, but you can also have what's called auxiliary tasks. But it really depends on instantiation, whether these are like auxiliary tasks, or you really care about all of your output tasks, so that they are kind of, you want to reach, not use one to improve another main task, but you want to solve them all in one go. And note here that a task, I'm talking about tasks here, but in NLP, these tasks can be really many things, and they can be, languages. They can be really different, the same language, but different tasks, or they can be different genres or text domains. So this is really, really a broad notion here that I'm taking as an NLP task here. And in the field, we have seen really huge progress in the last years due to deep learning, as all of you know, and also use in your own fields. And in deep learning architectures, multitask learning is really, really attractive, because you have a lot of variety of encoding mechanisms, but multitask learning, you can then have these additional decoders and very different decoders that you can use in order to learn your model. And that makes it very, very attractive. Now, if we step a little bit back, why would we be interested in MLT? Well, obviously for, actually for you can see two ways why. One is the scientific value. In NLP, we are interested in, this question of modeling language by the machine and making the machine understand language. And while we are still quite far from that, I would say jointly solving related problems gives us a way to reach into this goal quicker. And from a practical perspective, it's really more efficient learning, sometimes even simpler, or often also better modeling. So another perspective is perhaps a bit more detailed, is you can see this as a way of regularizing your models if you use auxiliary tasks. And in that way, using MTL to improve model accuracy. But you can also see this as enabling easier zero-shot or transfer learning. So you can have a task for which, say, you're interested in a certain language and a certain text domain. You might not have, the exact data for that domain you're interested in, but you might have similar other, from data in other languages for that domain, and you can exploit that in order to bridge this gap, for instance. And besides that, it's often also the case that we are now building these bigger models, which can be more efficient in one way if you apply them to different problems. And this is really like an overview a little bit on what I'm interested in general. So I'm interested in transfer learning and all sorts of problems that appear with transfer learning. And in this talk, I will focus on point 3 and the multitask learning perspective, and how can we use this for NLP. So in the rest of the talk, I will go a little bit. So I thought about setting it up, in fact, as a bit of a history talk to show you where the field is right now, and where we have been, how we did go into this area, but only on this problem. And but then try also to connect different perspectives of multitask learning, and in the end, show you some recent advances and open challenges. So I hope you are still with me, and let's go and have a look. So now, is multitask learning actually something new? No, right? I'm pretty sure actually a lot of you have probably used it already, and it's something which dates back decades ago. It was just not very much used in essentially our field for quite some while. But probably a lot of you know, since you are in a virtual world conference, a lot of you might know Alvin, and Alvin was one of the first self-driving cars, not the first, but sorry, I should in fact change this, one of the first self-driving cars. But there was an interesting application of multitask learning already in that application, in the sense that they wanted to try to improve the model by deriving properties of the data and using them as additional tasks that were exploited during learning to make, in a way, the model more aware of the problem itself. So where the road is on 1 or 2 lanes, the location of the left, all this kind of data properties were used and cast as auxiliary problems in order to improve the main task of devising the steering direction. So this was like one of the first applications or early applications in machine learning to improve, say, the steering direction prediction by adding these auxiliary tasks to the model. There is also another interesting application from early ML in, say you have patients and you want to predict their mortality rates, and it might be expensive to do the blood test. So the idea here was to, instead of having this information needed at prediction time, transform it into an output variable and try to predict it at the same time to get future lab results. And while also improving mortality rank prediction. So it's an idea that's really dating back, and these are just 2 examples that show that early applications of multitask learning. Now, let's have a look at MTL in NLP. And if you look at one of the first applications, that's actually, in my next slide, I'm sorry for that. So, but what we see in NLP is a recent really shift towards deep learning. And it's come to NLP a little bit later than to say speech, where they used deep learning much earlier, or image, computer vision. But in NLP, we consider 2015 as really the year where the deep learning tsunami hit our conferences. And what you see here is just a list of, a query of titles, including neural and deep learning. And there's really a boom in 2015. And what came with this is essentially the multitask learning, wave, I would say it, because a lot of the modeling then used, once we were ready in using deep learning and representation learning, moved to, hey, how can we now deal with this problem of learning from multiple tasks at the same time? And so this is where I would like to go next, in showing you a couple of selected examples on where multitask learning works in natural language processing. So a very early paper, in fact, dates this wave, predates this wave, and this is Colbert and Weston. And what they did is they had looked at several NLP tasks, but what they used as a multitask learning objective here was the sharing of the lookup parameters in these two tasks. So it was a very simple form of MTL where they shared the parameter space. And what they did is they tested this, in this case, on semantic role labeling, so finding the predicates in a sentence, some semantic predicates. And what they were trying to improve this by including other tasks as auxiliary tasks, like what are the word class part of speech, what is chunk information, but interestingly also, language modeling, meaning when doing the semantic role labeling, you also predict the next word. And that was one of the, this bluish line was one of the one with the very low error rate, which could help improve the black line, which is just a model learned on supervised data for semantic role labeling. So from then on, we saw a lot of new applications of bringing even tasks together. So there's here an example of improving machine translation with a sequence-to-sequence model by not only doing the translation task, but also doing, a simple form of a syntactic parsing at the same time. So transforming the parse tree into a linear structure and, sequence, and predicting the sequence as an auxiliary task. But what about more distant data? So these were, other NLP tasks which were mostly used besides language modeling. And we have done some work in this direction here on, there's the whole area of cognitive science and cognitive traces of human behavior. And one of them is, for instance, keystrokes. And this is something I've worked on a bit earlier on in using kind of the typing behavior from, the typing from keystrokes and the timing in that as an auxiliary task, and showing that that can help syntactic chunking. So there is, information out there in data sets that are not obviously labeled for the task at hand, you can also try to think of using for your application domain. Other than that, a lot of interest is also on improving models across languages. And when you do this, one of the problems is that you might get noisy labels for a label for the language at hand. And you can also there use multitask learning and say, okay, I have my manually annotated data here on the right side, but I also have, now another source of information, which I transferred from distantly supervised data, but I have this at hand. And instead of, just simply merging them and treating them as the same kind of source of information, I can model them in two different ways. And in that way, exploit again a multitask learning perspective and improve my modeling. So you see, right, there are different ways of looking at data and what are kind of either derived properties or distantly weakly supervised labels, or even language model objectives that you can add to your main problem at hand to improve the modeling. We can go yet again to another area. So from Coxeye to cross-lingual to images. And there's a broad area also in NLP, which is touching upon language and vision problems. And also there, we saw quite a couple of applications of trying to use visual information for solving NLP tasks. For instance, that's one direction, not the only one. And what we see here is an example of a paper where they try to predict the translated sentence, like here a girl eats a pancake to ein Mädchen isst ein, yeah. But what they do show in this paper is essentially when the decoder also tries to imagine the image that corresponds to the sentence, that they could get an improvement. Again, with multitask learning objective here. We did work also in this language and vision space, and I want to show you this study here. So we focused on the guess what data set. So it's a game where there are two players, and one player has in mind an object in the image, and the task is to determine what is the object the player has in mind. And what we developed here is a system. I'm actually not sure you can see my right slide with this. Can't get my mouse back. But what we did here develop is a system which uses, a model, an agent that guesses the object, but also asks the same question. And this was modeled previously as two separate models. We devised a grounded encoder which encodes the image and the previous dialogue into a joint representation, and use a multitask learning perspective to couple these two objectives so that they share the information. And in this way, we could also improve the modeling. So here, multitask learning was used as a way of model grounding in a language and vision task. All right, so hope you're still with me. I just want to give you a couple of perspectives on MTL to tying these things a bit more abstractly together. So MTL, we can see this as learning from distinct views. If you think back at this Alvin example, for instance, then you could think of different data properties that you can derive and use them as auxiliary tasks. Similarly, for NLP, you can think about, properties of words, how frequent they are, for instance. And that's what I've been using also earlier on trying to bias the model towards certain, words. And that you can see as a distinct view on your data that you can use in multitask learning. One really powerful mechanism is that you don't need data labeled with multiple layers of annotation. You can use this as combining very diverse sources of data. And here again is an example of using like the keystrokes, but you can also use case, or this example of weakly supervised data that you transfer from a noisy source. Doesn't necessarily need to be on the same data, but that's also enabled via multitask learning. And it's really about, sometimes certain tasks are better at another hierarchy in the model. So you can also think about lower level or like a cascading kind of approach with multitask learning. However, we have also seen in NLP that it's not always the case that multitask learning helps. And we have done a study on relating MTL to data properties and seeing first of all that it wasn't working always. And that we can find a little bit of information in the distribution shape of the auxiliary task in order to guide us on finding whether it works or not. This has since been, if you look at the other approaches like the Decathlon paper, where they essentially cast everything as a question answering problem. And if you look at that paper, you also see, okay, now we have one model for many tasks. Sometimes it wins, sometimes it loses. So it's not always clear that really going this way is very, very helpful. So here is really a lot of more to be done in understanding when, the limits of MTL, for instance, in NLP. And at the same time, most of the work I've shown so far is actually also, we touched upon this earlier in the question, this is still an LSTM, right? So most of the work was so far on pre-contextualized embeddings. So there was a lot of work in trying to change the architecture, the way it's shared, or even, on the right side, you find this loose network, which tries to learn when to trust which task, which is very architecture specific and not so easily transferable to the new methods. And in fact, that brings me to the last part of the talk on giving you a little bit of a perspective of recent advances and challenges and an example of what we have been doing here as well. So the main question, in fact, arises, now we have essentially contextualized embeddings like BERT, And they are kind of the new, if you think of, I here try to summarize it. Multitask learning in the early days was 2016, 17 was a really, really big hype on this, but still tied to, what the models we used back then, LSTM, CNNs, while then came the transformer paper and the large pre-trained models, and they essentially the whole of the encoding is now replaced with a big pre-trained model, and there is the decoders on top, which you typically fine tune nowadays. But the question arises then, how can we use these models still to do multitask learning? Is it even beneficial? To go even one step back, and then, even if you think about BERT, this is a language model that tries to predict masked tokens, but it actually is already a multitask learning model as well, because it's also trained on predicting the next sentence. And so BERT in itself is a huge multitask learning model. So our field now kind of completely relies on this technology. So how the question, one recent paper in fact used BERT as an example of a contextualized encoder, and used then, hey, we can actually do the same, right, in adding tasks at the output layer node. And this is a paper that showed very good results on what's called the glue task in improving sentence classification, pairwise text similarity, and so on problems. But now with the much, much stronger encoder. But beyond that, what happened in recent years is really a move towards bigger models that encompass, like already the model here encompasses a lot of the tasks, right? That we earlier treated as single problems. But what is really interesting to see is that it's also going more towards many, many more languages. And here's an example of dependency parsing. So the Universal Dependencies project is really creating parallel data in many languages in the same or similar annotation scheme. And this is an example of a paper from last year where instead of modeling all the tasks which are part of universal dependency parsing, like post styling, features, lemmatization, and the dependency tree itself as separate tasks, the paper produced a single multitask learning model for 75 languages all in one go. And if you look at the results, so they are really impressive, but we need to zoom in a bit more, is that this really is a single model on all of these languages, which was essentially outperforming often the models which were trained on the specific languages themselves, and also enabling zero-shot learning. So again, now we have a model that can, since it's relying on BERT, which can contain more languages than the annotations you have at hand, we can also get dependency parsers for languages for free, essentially. All right, let me see. Okay, I have still some time left. I want to quickly go into an application what we did recently. So one area in NLP which has, was a bit, which is very useful from an application perspective, is biomedical event extraction. And we were asking ourselves, can we actually improve BioNLP with multitask learning? Because the state of the art of what is biomedical event extraction, it's a structured prediction task where you want to identify links between, or this graph between entities in the sentence. So you have entities or trigger, what they're called, also proteins, and links between or arguments between these triggers and entities, but they can also be nested. In the state-of-the-art systems were still, based on essentially a pipeline of first identifying these triggers. So the entities are given, you have the triggers, and you want to construct this structure on top. And it's really a two-stage problem, or treated as a two-step classifier. And we were interested in, hey, can we actually simplify this by creating one model that does it all in one go, and then also can do it much faster. And the idea was inspired by some work on dependency parsing to create an encoding, a linearization of these event structures at the word level. So for each word, we're trying to predict what is the entity or the trigger it belongs to, but also what's the relation and coupling this in such a way with dedicated decoders that we can do it all in one go on top of Earth. And what we observed here is by doing this, or maybe I was a bit fast, so we are linearizing these events into essentially word level tagging tasks. And now we need to, since there are, cases where these structures can be nested, we need to have a special multi-level decoder as well. And we can model this all into a multitask learning model in order to get then the structure out in the end. And we compared this to prior work and saw really that we got a huge performance boost on this data set here. But what we also saw is that multitask learning was really important. So if you use the model and remove the multitask learning objectives, then you see quite some drop in performance. But what we also saw is a lot of work was focusing on the entities being given. We could now, since we have one system which does all in one go, we could test how good are we actually doing when we don't have this information at hand. And then finally, we also did the comparison to the best freely available system, which was based on the pipeline. And we could see that we could really get a much faster system, even though there is this, the big model behind it. All right, so this was zooming a little bit into our own work, but I want to touch up on two more recent advances, which I think are very important and very interesting to look at. Because so far, the multitask learning I've been showing you is mostly a kind of hard parameter sharing setup where you really learn the task at the same time. But what about knowledge transfer in sequence? And also what about other ways of transferring knowledge from one task to the other? In fact, one of a really recent paper was ERNIE 2.0. And while we looked now at multitask learning, like the second row here, learning them all in parallel, there is this other area of continual learning where you are assuming you get the task only at a certain time interval, so one after another, not having access to all of them at the same time. But the idea here of this paper was essentially to couple these two, multitask learning, continual learning, that you are getting a task in one at a time, but you don't, you don't assume the data is gone. So you keep a multitask learning objectives as you go along. So you're growing this network, and in that way, getting benefits by and less interference with forgetting by still learning all the tasks at each step. And they have shown that they can improve their modeling by very simply coupling continual learning with multitask learning. So I think there is a lot more to be done in this area, which looks very interesting. But there's also a question of how to do other knowledge transfer. And this is the last thing which I want to end up with, is a very recent work which couples multitask learning with knowledge distillation. And the idea here is to have a teacher-student network where the teacher is guiding the student by, instead of learning from a gold distribution, gold label, as in supervised learner, you have the other teacher model that provides you a distribution over labels, and that helps you in order to guide your model better. And they have shown in this paper that this kind of merging soft supervision via distillation and doing with an annealing property, so that you're essentially first relying more on the teacher and then slowly moving more towards the gold annotations, is helpful in multitask learning. And they've shown it again on the glue task and seen big performance improvements when doing this. Essentially, you're creating single models for each of the tasks, but use them as teachers in order to build your multitask learning model. So you have the overhead of having these single models during training time, but in the end, you're ending up with a model which is much better over all of the tasks together. There's a lot of open challenges, I think. So these two are examples. So when do you decide what is related, and how do you devise curriculums? Another important aspect is multilinguality and how far we can really go. So I've shown you this example by parsers, with 75 languages, but how far can we really go in parsing, in machine translation? And there is something called the course of multilinguality currently happening. And at the end, yeah, trying to find inductive biases from symbolic knowledge and how to integrate that into neural models or MTL models. So to wrap up, I've tried to give you quite quickly, honestly, an overview of what's happening on MTL and NLP. And we've seen examples where this can be really helpful in improving modeling. And it's really a flexible framework with a lot of opportunities, but also a lot of things to be discovered in future. So I hope I have given you some grounds on hopefully also exploring some of this in future. And with this, I would like to end my talk, and I'm happy to take questions. Thanks a lot.
Okay, thank you very much. Very interesting. And yes, I got some questions on the Q&A, but some of them are quite long and we're a little bit short of time.
Yeah.
I'll ask the shortest one.
Yeah.
Is there an understanding if similarity or dissimilarity between tasks could actively help or make MTL harder?
That's a very good point. Actually, this is what's assumed, that task relatedness helps, but it has also been shown that sometimes not having two related tasks can also help. So it's actually an open question. I do think there is more to be gained by understanding this and guiding learning, but it's very little study. That's more like an empirical study so far. So if you have, if you know some pointers in other fields, I would be happy to hear. Yeah.
Okay, thank you very much. So I encourage the questions makers to make short questions, because then they might be asked. But could you please, Barbara, if you have please look at the Q&A, and you can also answer the longer questions offline, perhaps.